Hi everyone, my name is Happy Abiola, and on today's lab I'll be doing my first hack on my Cubase machine, Cubase 1, and I'm just gonna dive into it. So on this slide it shows the target and objectives of my lab test. So I'm going to perform the Nmap scan on my Cubase 1 machine. I will also conduct the enumeration and footprinting of the Cubase machine 1, and also look into the flaw of hypothesis methodology. I will also identify the vulnerabilities and flaws in the open port. And here is my IP config for my IP address for my Kali Linux box. And it shows that my Kali Linux box IP address is 192.168.56.102. So I did my Nmap ping swing on 192.168.56/24, and then this shows that my Cubase 1 machine IP address is 192.168.56.105, and the open ports under these machines I have port 22, port 80, port 111, 139, port 443, and port 32768. And under the ports I have the state which shows that they are all open, and the services are also next to them. So for port 22, it shows the service is SSH, and port 80 the service is HTTP, and then goes on to the rest of the ports. And on my next slide, just to be sure that those ports are truly open, I have to test run my port 80, and then go to, open an Apache web server, and it actually came up and running, and that shows that the ports are truly open. And here is the scan I did on the operating system, and which I used the Nmap -0 192.168.56.105. So this one shows the services on which these ports are. So the port 22, like I said earlier, runs under SSH. Port 80 runs under HTTP, and so on and so forth. And on my next slide is the services scan Nmap, which I use the Nmap-SV on the Cubase machine IP address. And what this one actually did here is it actually shows the version of this port. So the port 22, the service is SSH, but the version of it is OpenSSH 2.9, and the protocol is 1.99. And then for the port 80, the same thing too. It shows the version of it is Apache, and it's HTTPD and 1.3.20. So this one shows the version of the services that is running. And this is my intrusive scan, which I use the Nmap-P-A and then the Cubase IP address. And this one actually shows which Kali I'm running on, and it shows that I'm running on Kali Linux 2.4x. And then it shows here also that my network distance is on high on 1 hop. And then these are the additional Nmap command that are not used on the video. Run the Nmap-st on the Cubase machine, and this one also shows that the ports are open and the services that they are running on. And I also use the Nmap-sp on the Cubase machine, and which is also shows that my Cubase machine is 192.168.56.10. And additional one that I actually ran is the Enum4 Linux on my Cubase IP address. So this one literally shows that the status of my Cubase machine, and which shows that the Cubase machine is active and running. So here's another mode I did on port 80, port 443, and that shows that the ports are open and running. And then here it says explain the flaw hypothesis methodology. So the flaw hypothesis methodology is a systematic approach used to identify and analyze flaws or weaknesses in a particular system, process, or theory. And then this methodology comprises 5 distinct steps, which includes information gathering, the flaw hypothesis, the flaw testing, the flaw generalization, and flaw elimination. So during the information gathering, the tester gained a comprehensive understanding of how the system operates. So this involved thoroughly examining various aspects such as the system design, implementation, operating procedures, and its overall usage. So using the information acquired from this step, you did not take into consideration the vulnerability identified in this system. So the tester formulates potential flaws that may exist within the system. So the flaw testing phase involves the tester conducting tests on the hypothesized flaw to determine the existence and exploitable nature. So if a flaw is found to be non-existent or unable to be exploited, the tester will return to the step 2, which is the flaw hypothesis, and then they will revise their hypothesis. However, if the flaw is confirmed to be exploitable, the tester will move forward to the next step in the process. So after successfully exploiting a flaw, the tester make an effort to extend their understanding by identifying vulnerabilities that are similar to the other one they found. So they then incorporate the newfound knowledge or hypothesis into the second step and continue the process until the testing phase is completed. So this tester provides a suggestion on how to completely remove the flaw, or suggest using maybe patching management control to improve the situation and minimize its impact. So by doing so, they aim to enhance the overall quality and effectiveness of the system or the product being tested. And on my next slide, I'll be here is the hypothesis based on my findings, and I use Nikto on the QP machines, and here are some of the flaws which I'll be explaining later. Some of the flaws are in here, but I actually I'll be explaining that in my next slide. And here are the flaws I found on port 80 and 443, and for them, the server says the may leak inodes via e-tags, the anti click jacking S-frame is not present, the X content type option either is not set, the OpenSSL appears to be outdated, the Apache appears to be outdated and up and is vulnerable to a remote DOS, DOS and possible code execution. So it's also vulnerable to overflow in MOD rewrites and MOD CGI. So the system flaw vulnerability in Samba. So I scanned the network to find vulnerability host and identify the Samba version. So I used port 139. So I ran nmap-139 then -p and then the QP address, and which shows that the port is actually open. And then I ran the searchploit script to actually show me all the flaws and vulnerability on the open port. So some of the flaws I found on the open port for the Samba, the port 139, the version is outdated. It can exploit. The exploit allows attacks to launch code and gain root access. Then the remote buffer overflow. The format string is bypassed. The exploit uses the call chance to open function in chance 2 to create a buffer flow. And then the flaw and vulnerability found on port 111 and 139 and 443. And you can see around the nmap script 1 and on the IP address for the Cupri machine. And you can see that the risk factor is very, very high, and the state is it's vulnerable. So the OpenSSL, before was on 0.9, and then it does not properly restrict processing of change cipher spec message, so which allow man in the middle attacker to trigger use of zero length master key in setting OpenSSL to OpenSSL communication. And then here I'll be talking about the vulnerability map of a system. And here are the stages of how the vulnerability map of a system run. You verify, we assess, and we assess, we verify, and we mitigate. So to create a vulnerability map for a system, it is important to understand the system's architecture, the component and functions. So this involves identifying the hardware and the software elements and how they connect. So classifying vulnerabilities based on severity and potential impact helps prioritize the most critical ones for immediate attention. So the likelihood of the exploitation should also be considered to assess the risk. So once the vulnerabilities are identified and categorized, they can be mapped to specific parts of the system to understand potential attack route and vulnerable areas. So this allows for targeted strategies to mitigate vulnerabilities and allocate necessary resources for resolution. So after understanding the structure of the system, so the next step is to analyze the potential vulnerability. So these include identifying and listing all possible weak points that could be exploited by attackers. So these vulnerabilities may be caused by design flaw, software bugs, misconfiguration, or insufficient security measures. So overall, creating and using a vulnerability map for a system involves a systematic approach of understanding the system, identifying the vulnerability, categorizing them based on the severity and likelihood of the exploitation. So mapping them to specific components is very, very important, and regularly updating the map to include any changes or new vulnerabilities. So this process helps organizations proactively manage security risk and protect their system. So it is important to continuously update and maintain the vulnerability map as the new vulnerability are discovered or patched. So regular assessment and testing should be done to identify any new weaknesses and caused by system changes or involving threats. So by keeping the vulnerability map current, organization can address security risk and keep their system protected at all time. And on my next slide, here I'll be explaining the flaw I found on my OpenPort, and I did a little bit of research on them, and then I'll also be talking about the possible root causes of these flaws. So for the port 80, port 22, I found that the anti-click jacking S-frame is not present. So the website is at risk of click jacking attack because it is missing an S-frame option header. So this header is used to prevent hijacking, click hijacking attack by specifying whether the browser should render resource within a frame or an iframe. So clickjacking is when an attacker tricks a user into clicking a button or click on a frame page, then redirecting them to another page. So this technique can also be used to hijack keystrokes, making user unknowingly enter sensitive information into an attacker control frame. So if your vulnerabilities cannot find a missing anti-clickjacking header, it means your website is currently vulnerable to clickjacking attack. And on the other one, have the OpenSSL, it appears to be outdated. So the OpenSSL package installed on one of the hosts was identified as being outdated and subject to a heap corruption bug. So it is advised to upgrade the outdated one or the vulnerable OpenSSL package to the most recent stable version of it. And then for the system flaw on the Zamba, I found that the exploit using the call trans open function in trans2 .c to create a buffer flaw. So a security flaw has been identified in the Samba software, specifically related to a buffer overflow vulnerability. So this vulnerability arises when user provided data is copied into a fixed size buffer, creating an opportunity for malicious individuals to potentially tamper with the critical memory area by overwhelming an affected Samba server with excessive data. So exploiting this vulnerability successfully could result in unauthorized execution of arbitrary commands, utilizing the privileges associated with the Samba process. So it is important to note that Samba version 2.2.8 and earlier, as well as the Samba TNG version and earlier, are susceptible to this kind of vulnerabilities. And thank you so much for watching and listening. And here are my references. And do have a good one. Bye.